K nearest neighbor is one of the supervised machine learning algorithms. A very simple algorithm, very easy to understand. Okay, and we will see what exactly K nearest neighbor is. Okay, in the case of K nearest neighbor, we need to tell the value for the K. We need to define the value for the K upfront. Okay, so that the model will get to know how many number of neighbors it's supposed to use it. How many number of neighbors it is supposed to use. Don't worry about neighbors, all the things. I'll explain you in a moment. Okay, so K is nothing but the number of neighbors. Okay, how many number of nearest neighbors that needs to be considered. Okay, so it is the K nearest neighbor algorithm is also called as a lazy learning or instance based learning. Okay, so what is learning? We know learning, right? Storing all training instances, and classification is right. We can do classification as well as regression using K nearest neighbor. It is a lazy learning. I'll tell you why it is lazy learning little later. Okay, so there are three steps in terms of implementing the K nearest neighbor algorithm. It's a very simple algorithm. Okay, so first you need to define the value for K. Okay, and choose the number of neighbors. Okay, and find the K nearest neighbors of the new data point based on the distance. Assign the new data point to the category based on the majority one or class labels. You heard about this term yesterday's session, right? We discussed about majority vote as part of random forest. Random forest is one of the decision tree algorithms. It is also a popular machine learning algorithm in decision tree. In the case of random forest, we have multiple classifiers, and what the algorithm does is it combines all the classifiers output, and based on the majority vote, it assigns the predicted class label. Okay, that is what we discussed yesterday. That is how the random forest algorithm works. Here also somewhat similar to that. It goes by the majority vote. Okay, in the case of classification, look here, step 1. Let's say here K is equal to 1. Look at this. I plotted the data, the existing data. I could see that this observation is very nearby to this observation. This record is closer to this one, and this record is closer to this one. So since these records are closer to each other, right? This falls into one specific class. This falls into one specific. These observations combine as part of one specific class, and these two, are formed part of one class. Okay. Now we have a new instance came in. It is, let's say this is a brown colored one. We need to the algorithm has to classify this new instance. In order to classify this instance, it has to compare with the nearest neighbor. Okay, so for example, in this case I have given K is equal to 1, right? So for this observation, this one is very closer. If I specify K is equal to 3, let's look at this example. Okay, let's say we want to classify this new instance orange class, because the rest of the observations were already classified. Okay, now I want to classify this new instance or the new record. Let's say this guy is a new customer. We want to classify whether this customer is going to default or not. Let's take a simple example. Okay, fine. In that case, what will happen is you will have to define the K value. Let's say if you mentioned about K is equal to 3. So what happens is in step 1 you mentioned the K is equal to, let's say K is equal to 3. Okay, in this case we have 3 potential classes are there, this one and this one, 3 classes are there. So we mentioned, let's say K is equal to 3. What the algorithm does is it tries to find out the distance between this new instance with the rest of the observations. It has to find out the distance between these two observations, these two observations. Only then the algorithm get to know which observation is close by to this new instance. Unless computing the distance between the observations, how will it get to know, right? It has to find out the distance, compute the distance between every other observation with this new observation. In that case, let's say, the second step, right? It start by calculating the distance between the orange and all other points. So in this case, the distance between these two observations are 2.1, and between these two is 2.4, and this one is 3.1. Okay, 3.1. Likewise, it computes the distance for all the observations, and if you specify k equal to 3 of the computed distances, right, it will consider only the 3 nearest neighbor. So in this case, let's say the 4.5, let's say this is 4.5 and this is 3.5, something like that. Okay, and this is, let's assume that this is the one is closer in this class, and in this class this is the one is very closer, this is the one is closer. Let's say you mentioned k is equal to 3. It takes only the 3 nearest neighbor, these two and this one. Okay, anyhow, I will just move this little bit logically, right? I'll just move this close by, right? So compared to this one is close by in this class, right? This is 3.1 and this 2.1. So likewise here also it has to compute the distance. Look here, compare this one, the distance between and this one is 4.5. Okay, so now if you specify now the distance between the new object and the other existing observations, the distance got computed. The next step is, since you mentioned k is equal to 3, you can specify whatever value you wanted, but when it comes to k nearest neighbor, it is the best practice to choose the odd number. I'll tell you why odd number you need to choose. Okay, let's say I have chosen k is equal to 3. 3 is an odd value, right? It is not even number, it is an odd number. So it takes 3 nearest neighbor, 2.1, 2.4, 3.1, because 4.5 is little far. And also you mentioned k is equal to 3. Take only 3 nearest neighbor. So compared to this, these 3 are very close by. The next step is, of these 3 nearest observation, right? It will try to find out it will go by the majority vote. Let's say these 2 observations says, let's say all these 3 are right. These 3 observations, of these 3 observations, 2 observations, the green colored one are non-defaulter. This one is a defaulter. Let us assume that way. Since you have mentioned k is equal to 3, this new instance, it takes into account of these 3 nearest neighbor, and it compares this one with this one and this one, right? And then what happens is, of these 3 observations, these 2 observations are non-defaulter, whereas this is the defaulter. So in this case, it goes by the majority voting. So majority voting is non-defaulter. It vote on labels based on the majority vote. Okay, let's look at this simple example so that you'll be able to understand very clearly. Let's say I wanted to classify this guy. So this person, this customer has applied for a loan. My model has to predict the class label for him given the past data. So these are the data are already available. Now what the algorithm has to do is, it has to compute the difference between this observation with the rest of the observations. How it computes the distance between this observation and the rest of the observation, that is where we have something called Euclidean distance. Look here, this is what Euclidean distance. It uses a distance metric called Euclidean. So Euclidean, the formula for this one is square root of this one, x1 minus x2 whole squared plus x2 minus x3 whole squared. And here this is a categorical variable. This cannot be used. And also it is a dependent variable, right? It is a dependent variable. These are the features. These are the independent variables. 48 minus 33 whole squared plus 1,42,000 minus 1,50,000 whole squared, and we take the square root of everything. The distance between these two are 8,000. Similarly, 48 minus 45 whole squared plus 1,42,000 minus 51,500 whole squared, and if you take the square root, I am getting this one. And similarly, if I compute the distance between this observation with this observation, I get the distance is 82,000. it keeps computing the distance for every other observations, okay, like this, okay. And now if you specify k is equal to 3, what happens is, so now you tell me these are the distance values, distance computed by my model for all the observations. The distance is calculated, the distance was calculated. Now you need to, if you specify k is equal to 3, so what are the 3 nearest neighbors for this observation? These two are close by, right? Obviously, of the given 3 nearest neighbor, these 3 are very close by. You can take these 3 neighbors also, but these 3 are, this one is too far from this guy, right? 3 nearest neighbor it takes into account. Now of these 3 nearest neighbor, it will look at this target column and it goes by the majority voting, okay. So it is, it is somewhat similar, you, or probably you can think this way, right? If you compute the distance, that means this guy and this guy is somewhat similar in nature, okay, similar when it comes to the payment behavior or other demographic behaviors, okay, something like this. That is what intrinsically it tells us, right? The k nearest neighbor. So these two records, obviously, let's say here 1,50,000, 1,50,000, that means 0. The difference is, the distance is nothing, right? That means these two guys are, let's say both the guys are age is same, right? 48, here also 48, or let's say this guy's age is 47, 1,43,000. In that case, the distance will be very less, very less. That means this guy's profile and this guy's profile is somewhat matching, near matching, right? With the help of k-nearest, that is the reason why in the case of data imputation they use KNN algorithm also, okay, the KNN algorithm. So you remember I threw one scenario as part of data imputation. By, let's say if the price is missing, how will you need to do some kind of conditional based imputation and all. Instead of doing this, you can use k nearest neighbor, okay. Some cases, again on a case to case basis, you are supposed to use it, some cases, but in general k nearest neighbor is enough, okay. Coming back to this, the 3 nearest neighbor for this observation is these one, right? These 3. So of these 3, what is the majority one here? N, right? So what is the predictive label for m? N only. It takes the, see, the first step is you need to specify the k value. Let's say the k value is 3, and what the algorithm does is it computes the distance between the new instance and with the every other instance in the existing data set, and it computes the distance, and then it takes the 3 nearest neighbors. Within these 3 nearest neighbor, it goes by the majority voting. You understood, right? Okay. Using k nearest neighbor, we can solve regression problem also. Let's assume that this is your housing price or loss given default. You gave loan to this guy in the past, and his age is this one, and this is the default amount, okay. In the case of defaulting, how much loss bank is going to incur? Let's say this is my quantitative variable. So in that case, it takes the 3 nearest neighbor and then it performs the averaging. The same thing is applicable in the case of the random forest. But in the random forest, it is not using nearest neighbor. It combines multiple classifiers, predicted value, the estimated housing price, and then it takes the average of it. Takes the average of all the decision trees estimated housing price. Right? The same thing is applicable here, but in decision tree it is not using k nearest neighbor. Okay, the k nearest neighbor only it is computing the distance. In random forest, it is not computing distance and all. Only similarity between this and random forest is random forest also goes by the majority voting by combining multiple models there. In the case of regression problem, it performs the averaging. Okay, But in the case of nearest neighbor, the same thing is applicable, but it uses the nearest neighbor. Right? How does this determines the nearest neighbor? Based on the distance. How the distance is computed? Using the Euclidean distance. There are different metrics are available. Euclidean distance, Manhattan distance, Mahalanobis distance. Likewise, different distance metric is there. This is the most popular distance metric, and most of the cases this is the default metric used to compute the distance. Okay, very simple one, right? This algorithm is very simple. Let's take this example, another example. Look here, this is the movie name, and the properties of this movie are defined here. Okay, the number of fights in this movie is 2, number of songs in this movie is 1, and this is my target variable, dependent variable. The type of movie is comedy. In the case of comedy movie, the number of fights is very less, and number of songs also very less. Whereas in the case of romance movie, number of songs are more, number of fights are not much. But in the case of action movie, songs are very less, fights are more. Now let's say you want to classify this new movie X-Men. X-Men is the action movie. You know the property. And if you compute the Euclidean distance between this and every other object, right? Every other observation, and you will obviously find the distance between these two are very close. So not this one. Yeah, X-Men. X-Men is 8, 2. Yeah, this is woman. Okay, sorry. 8, 2. 8 is 8 fights are there, and number of songs is 2. The 8, 2 is somewhat matching with this, right? So if you compute the distance, it is 6.08 compared to other observation. This is very close by. Hence, this movie will be classified into this category, action movie. X-Men is the category, right? So hope you understood with these examples. These are the different distance metrics are available. Euclidean distance, Mahalanobis distance, and city block, Minkowski. I listed out all kind of distances. Okay, and probably you can go through on these distances if you are very interested in exploring each and everything. But most of the time use Euclidean distance, and cosine distance we use it in some cases. Okay, I'll tell you when I cover about the NLP part. Okay, why we are using the cosine distance metric there, that I will tell you. And some cases Mahalanobis. In the case of fraudulent transaction, predicting the fraudulent transactions, right? In one of my past students, right, she was working in the fraudulent transaction modeling. In that case, she was using k nearest neighbor, but she was using the distance metric as this one, Mahalanobis. Okay, but in general, this is the one is used. Okay, the k distance metric, this is the one is used. And what is the advantage and disadvantage of this one, the k nearest neighbor? The accuracy wise it is good, but it is not sensitive to outliers. Hope you remember I discussed about linear regression, right? In the case of linear regression, it is sensitive to outlier. Linear regression makes some assumptions, but whereas here it is not making any assumption at all. Okay, and computationally expensive. So why it is computationally expensive? Just to predict one customer's loan, the default status, it has to compute the distance between every other observation in the data. Assuming that you have 1 million customers are there. Take for example in the case of Citibank, they have 25 million customers are there. To predict one customer's payment status, it has to compute the distance between the 25 million customers. That is the reason why it is computationally expensive, and it requires heavy memory. Okay, it works with numerical values and nominal values. Okay, if you have categorical variable, you need to convert the numerical value. That is also possible, you can do it, but you cannot use the text data here, like the categorical variable with the text values in it. You need to convert this into quantitative thing. And why it is called lazy learning? Because it has to compute the distance of one single instance with multiple observations, right? Hence, it is a lazy learning. That is the reason why it is called as a lazy learning. So that is pretty much about k nearest neighbor. Nothing else to talk about k nearest neighbor. A very simple algorithm. Okay, I'll just I restarted, right? So now, it will take some time to start the Jupyter notebook. What we will do is, in the meanwhile, let us jump into the clustering part, the unsupervised machine learning. So what is unsupervised machine learning algorithm is all about? So what is supervised we discussed so far. What is unsupervised machine learning algorithm is all about? So when it comes to machine learning, unsupervised machine learning, we do not need to supervise the model. We do not need to supervise the model. That means the algorithm doesn't require the labeled data. But it is quite challenging to get or to label the observations. Supposing you are given 1 million images, and you are tasked to classify which image falls into which category. In that case, in the case of supervised machine learning algorithm, you need to create the label for each and every images. It is practically impossible. It is possible, but it takes a longer time, right? It is painful, but especially you have 1 million, the huge amount of data. It is a painstaking process. Or you have to write some logic, and you need to do. But in the case of image, what kind of logic you write it? Right? So if you don't have the labeled data, then the unsupervised machine learning algorithm is very much helpful. Okay, it doesn't require the labeled data. What this unsupervised machine learning related algorithm does is, it self detects or discover the patterns and information that was previously undetected, or in case of any hidden patterns are there, any structure is there in your data, it self detects. It has the capability to self detect the pattern on its own without learning from the past data. It doesn't require the past historical data to train the algorithm. We don't have to train the algorithm here. Right? So here the unsupervised refers to the problem of finding a hidden pattern or structure within the unlabeled data. That is what the unsupervised machine learning is all about. The objective here is to model the underlying structure or pattern in your data set. Another example is, for example, if you show a kid, let's say a 6th standard kid, if you show an elephant, it tells very clearly this is elephant, right? It doesn't require any training, right? In the case of supervised machine learning, we need to show the image, we need to give the label also. But even if you show any image, they say 6th standard, 10th standard kids, they can tell very well without learning, right? It can tell, oh yeah, this is the one is this. Right? Fine. So in the case of unsupervised machine learning, there are different types of algorithms are available. Clustering algorithm is available, principal component analysis there, market basket analysis there. And in clustering is the most popular one. In the case of clustering, right, so what the purpose of clustering is to form homogeneous groups within a data set based on their internal pattern. Let's take a simple example. Look at this image here. Let's say I have customers. I have thrown my data to the machine learning algorithm called clustering. What it did was, it grouped the data into 3 different categories. So if you look at each and every group, which is nothing but the cluster, each cluster has a homogeneous data in it. What do you mean by homogeneous? Right? Similar. Right? We could see, the observations that are there or the objects that are part of these clusters are similar in nature. Here also these are similar in nature, right? So that is why, right? In the case of clustering, it groups the similar ones and separates the dissimilar one. That is what called as clustering is all about. Okay, so that is what we do it. Uh, so it is also called as segmentation analysis or grouping or taxonomy analysis. Different people use different terms, but when it comes to machine learning, or if you talk to any data scientist, they use clustering only. They use this term clustering. But marketing guys, they talk about segmentation. Can you please perform the segmentation analysis or taxonomy analysis, something like that, or product taxonomy, something like this. Okay, there are different types of clustering techniques are available. One is k-means clustering, other one is hierarchical, DB scan, expectation maximization. Let us start to look at what is k-means clustering now. What is k-means? Like k nearest neighbor. Even in the case of k-means clustering, we need to tell ahead to the algorithm how many number of clusters that needs to be created. Okay, it is an unsupervised machine learning algorithm. We use the k-means clustering is used for the quantitative variables like k and n. Here also we are supposed to use the quantitative variable, and the clustering helps us to summarize the properties of cluster. The input to the cluster is numerical value. You need to give the input as the numerical variable. If you have the mix of both quantitative and categorical variable, you need to convert the categorical variable into numerical. Okay. Why the data are supposed to be, the variables are supposed to be numerical? Here also in k-means algorithm, it uses the distance metric like in the case of k nearest neighbor algorithm. So what is the output? Let's say I have thrown let's say I have used in my data set I used all the quantitative variable, and I use that data set to build my k-means algorithm, k-means clustering. What am I going to get? The output of the k-means algorithm is you will get the optimal value for the centroids. Optimal value for the centroids. At this moment, you just think the centroids are nothing but the central value of your cluster. Okay, supposing for this cluster, the central value might be here, right? The central value be here, somewhere here, somewhere here. The central value is called your centroid. When you build a cluster, k-means cluster, you can expect the output as the optimal value of your centroids. We can it is often suitable for large amounts of data. We can use k-means clustering for the huge volume of data to find out the structure in the data. And also the k-means clustering is used for the exploratory purpose. If you have given the data, right, so we start explore the data using the visualization packages, like in the case of Python, matplot library, and Seaborn, we use it to explore the data, to gain, right, in order to gain insights, we use the charts to explore the data. Similarly, you can use the k-means clustering or clustering technique to discover the structure in the data. You can use this also for exploratory purpose. Right? But the k-means clustering, right, is used as a lead into classification. It is basically exploratory technique to detect or uncover the structure of the data that you might not have noticed in the past, or that you might not have thought about it. Okay, that is the beauty of the the k-means clustering, or you take any other clustering, okay, it finds out the patterns which we never thought about it. Okay, so using the k-means clustering algorithm, you can do document clustering. Supposing you are given bunch of document, those documents are unstructured data, and you need to find out, right, which all documents relate to which topic. Which you are given three documents, but when you give these three documents to the algorithm, right, it groups the observation. It tells us, okay, this document is related to healthcare, and this document or this article or this document talks about entertainment, this document talks about sports. Okay, so it kind of doing some kind of grouping, right? So Google News, you might have heard about Google News, right? So Google News, when you type any keyword, for example US elections, right, it groups all the news that are relevant to the keyword whatever you typed it. They uses k-means clustering. I don't know now, they must be using the advanced NLP algorithms, topic modeling and so on. Okay, so earlier they were using k-means clustering to group the similar news. Google News, they were using that one. And shopping cart item grouping and image processing. Let's say you are given a bunch of images, so you want to find out which image belong to which group, right? You can do image processing and customer segmentation, navigation of search results, right? In that case, it is very much helpful. You can likewise, there are a lot of other use cases are there. These are the commonly used use case. Okay, the use cases. These are the common use cases. Okay. Now let us take this simple use case and understand how clustering is helpful in terms of making sense of the data or validating some assumption. See, when it comes to machine learning algorithm, right, when you build the model as part of the data science life cycle, we'll discuss about the life cycle probably in the next session. Okay, one of the stages of the data science life cycles is hypothesis, formulating the hypothesis. Okay, formulating the hypothesis. What do you mean by formulating the hypothesis? You want to make some assumption, okay, based on your past domain experience, right? Make some assumption. Let's take this example, okay? Let's take one, let's say one simple use case here. In this case, I represent a fictitious online retailer, okay, online retailer, and the unique selling point of this retailer is they make the returns process simple. Now you know very well Amazon, all the e-commerce players, they offer the return policy. They have some return policy. Within 7 days, you can return the product if you are not satisfied. Okay, so basically this encourages the customer, or it gives more confidence to the customers. Okay, even if I buy from this the e-commerce player, I can return it in case of I'm not happy with the product. The return policy is there. Now what we do here is, right, in this we take the data here. So I took the data here, and I make an assumption like the frequent customers are more valuable. Frequent customers are more valuable. This is the assumption or hypothesis that I am making it. I want to validate this. For that purpose, I am using the clustering technique. Okay, in this case, I have taken the variables like return rate and purchase frequency and the lifetime value of the customer. Okay, and I plotted. I use the clustering algorithm. Here, the different colors tells different groups. Here, this is group 1, group 2, group 3, group 4. 4 different clusters formed here. This one is says this one, okay, and this guy and these people are similar in nature. Okay, so the purchase frequency is less frequent, right? They are not frequently purchasing it, but the return rate is also moderate. Okay, moderate, low return rate, and less frequently they are if you look at here, these people are purchasing it more. Group 3 visits, look here, group 3 visits often, and the return rate is moderate, high lifetime value. But if you look at the group 3 is this one, right? Yeah, often. And group 4, they visit rarely. Group 4, in this case, the group 4, in this case, right, the group 4 visit very rarely, don't return purchases, right? Very rarely they will visit, but they don't return purchase at all. Hence, they are high average lifetime value. So here we categorize these people as, the group 4 as first. We ranked them as 1. Okay. So here what hypothesis I formulated was the frequent visits to my shop by the customers, right? Those customers are valuable customers. Those customers visit frequently, they are my valuable customer. But when I explored the data, I could see that visits often, the return rate is, visits often, return rate is high. The lifetime value is very less. They are ordering 10 items, but they are returning 10 items. They are using it for 3 to 5 days, it seems, and they are returning it back. In this case, the shipping cost is very high for the company. The cost, it is cost to the return is attached to the cost. It is cost to the company because we take the items returned by the customer without charging anything. Okay? The rate is very high here. So now what kind of inference you can make it here? Group 3, they visit often, the return rate is moderate. Right? Right? And are high value. They are high value. So why is it that the group 3 is ideal? By looking at this is what the question comes to our mind. Right? So what are the people they purchase in these 3, and then can we raise the lifetime value of our frequent customers, perhaps by lowering the cost of returns, or discourage the customers to return the products. Please don't return it, right? So probably by discouraging them, right, you can increase the lifetime value. Likewise, by exploring this data with your domain knowledge, right, you will find out solutions for various problems. On the one hand, you can come up with a strategy to cut down the return cost. First, find out why the customers are returning. Find out the group, right? Look here, the return moderate, lowest, but return rate is high. Why are they returning more? Right? Find out the reason for that, and then if it is very valid reason, then it is fine. But if you've taken the last 6 month data, and habitually if they are doing it, there's something wrong there, right? Flipkart, they do like this, though they say return policy is there, but they don't take it back. I saw 1 or 2 occasions, but though I'm not a frequent, oddly I used to order it in Flipkart, but when one occasion I want to return it, they did not take it. Discourage the customers based on the customer behavior. Okay, but again, you need to take a deep dive in each and every group. Look here, in the case of group 2, group 2 visits often, and group 2, look here, very often they are visiting, but the return rate is also very high. And take these set of customers and find out why are they returning it more frequently. If it is something wrong, right, if the problem is with the customers, then or the reason for returning the products are not reasonable, then you discourage them. Okay, and then here Group 1 visit less frequently, low return rate, moderate lifetime value. How can you increase the lifetime value? Probably you can launch some campaign to woo these customers to visit more frequently to your shop by giving special offers, something like that. Right? These are the measures that you can take it, or these are the action plan you can take it. By looking at this, uh, the cluster groups, the groups of the cluster, or the clusters, right? The four clusters, we're able to get more insights. The more the insights, you can come up with more action plan. On the one hand, you can plan for increasing your lifetime value. On the other hand, how you can target the least frequently visiting customers. So likewise, you can use clustering algorithm, K means clustering or hierarchical clustering, to explore the data, to validate. This use case I demonstrated how to use it in the case of validating your assumption. I was under the impression that those customers are more frequently visiting my shop. They are the most profitable customer. That is not true. So what is the next course of it? By looking at this, we have more questions, and also we come up with more kind of action plan in terms of cutting down cost somewhere, right? And probably increasing the lifetime value. Also, you can come up with action plan, right? It helps you to come up with various action plans, right? To cut down the cost and increase the lifetime value, so on and so forth. So next, let's try to understand how does this algorithm works. The K means clustering algorithm. Like KNN, the K means algorithm is also very, very simple algorithm. You need to define the number of clusters upfront. Let's say I specify the K value is equal to 3. That means create 3 clusters. Create 3 clusters. So when I specify the value for K is equal to 3, it initializes 3 centroids randomly. 3 centroids, it initializes it randomly. Next step, what it does is, after initializing the 3 centroids, it assigns the observations that are closer to the respective centroids. Once the assignment is done, it updates the value for the centroids. The assignment update steps are iteratively performed as long as there are no more assignments are done to the clusters. Like I said, K means algorithm. Also, you need to use the numeric variables. Okay, so I will explain this with example. Listen very carefully. You will be able to understand very, very easily. Even a 10th standard student was able to understand very clearly. Let's say these are the data set given to me. I just plotted it. Okay, these are the data set given to me. I plotted it. I mentioned K is equal to 3 to the algorithm. It randomly initialized the centroids like this. It created one centroid here and the square boxes. Okay, this one and this one and this one. The next step is assignment step. The case of assignment, what happens is the observations that were closer to the respective centroids, right? Listen, in this case, these observations are very closer to this centroid. These observations were assigned to this one, and these observations were closer to this one, and these observations are mapped to this one. These observations are very closer to this one. This one is, this one is closer to them, this one is closer. Look here. Since this one is closer to this and this one is closer to this, right? Look here, all these things are blue colored. This is red colored, this one. All we did was we specified the value for K as 3. It randomly initialized 3 cluster centroids. Next step is started assigning the values to the close by centroids. And it forms the initial cluster. Now the initial cluster is formed. So these 3 forms into one cluster, these 2 forms into one cluster. These values are falling into one cluster. The initial cluster is formed. Once the cluster is formed, the algorithm will recompute the centroid, which means the average. We studied, right? The average is nothing but the middle value in simple term, right? So when you compute the average for this cluster, this centroid will get shifted here, and this one will get shifted here, this one will get shifted here. That is what is happening. Look here, this one got shifted here, and this one got shifted here, this one got, earlier it was here, it got shifted here. Look here. So that is the reason why the k-means clustering algorithm is also called as iterative programming, right? Iterative in nature, okay? Iterative algorithm, not programming, iterative algorithm, okay? K-means clustering is also iterative algorithm. So likewise, right? So now it computed the new centroids. Again, it has to do the assignment. So with the new centroid, it will check which all observations are close by to this centroid. Look here, now this one became closer to this one. And even this one, is closer to this one. These all closer to this one. These are closer to this one. Look here. The next iteration, what will happen is, the finally, right? So all these things, right, including this one, 4. All these four observations were part of this one and this one and this one. By keep iterating the assignment and update step, it makes sure that it assigns or the clusters are stable. Right? As long as the clusters are stable, that means there are no more assignments are required. Right? So in this case, the cluster is stable. So even if you recompute the cluster in this case, the centroid, obviously it will remain as it is. If you compute the middle value for this, it will be somewhere here only, right? Again, it will be here only. See, even it might get shifted here, but still all these values will remain as it is. It doesn't require any new assignment. Hence, the cluster is stable here. Right? Very simple technique. Yeah, so ideally this is the one. Yeah, correct. This is the one, final cluster. Right? So this is what, to summarize, we assign the value for the key. It initializes the k centroids randomly, and it assigns the observations that are closer to the respective centroids. After the assignment is done, it recomputes the centroid. The assignment update steps are done iteratively as long as there are no more assignments are required to the clusters, or as long as the clusters are stable, the assignment update step will be iterated. Now the question is, okay, how does this algorithm knows this one is close by to this one is close by to this, and this one is close by to this? Like k and n, here also it uses different distance metric, Euclidean distance. This is a popular one. Okay, popular one. Let's take a look at this simple data set. Let's say I have 7 observations are there. I specified the k value as 2. K value as 2. The centroid, centroid value is 2. So 2 centroids will have to get assigned, right? Randomly assigned. So let's assume that in this data set, this first observation and the fourth observations were randomly assigned as the centroid. Now, how this observation is getting assigned to this cluster? Now we need to check whether this observation is getting assigned to this cluster or this cluster. We have 2 cluster centroids, observation 1 and 4. The rest of the values have to be assigned to either the cluster 1 or cluster 2. How it is getting assigned, that is what we are checking it. Look here, 1.5 minus 1.0 whole square plus 2.0 minus 1.0 whole square, and you need to take the square root. This is the formula for the Euclidean distance. If you solve this, you will get 1.12. And similarly, you take this observation. This is just a record number, you ignore it. 3 minus, this one you need to compare with this centroid. 1.5 minus 5.0 whole square plus 2.0 minus 2 minus 7.0 whole square. This gives 6.10. Now you tell me whether this record is close to this one or close to this centroid. Why don't you tell me that one?
Close to the first one.
Very good, right? It is very closer to this one. Of these two, right? The Euclidean distance for the observation 2 is closer to cluster 1 only. Hence, this one will get assigned to this cluster. Now, these two observations are falling in single cluster. Now, what happens is, look here. Now, the initial cluster is formed. It has to update the new centroid, isn't it? So 1 plus 1.5 divided by 2 and 2 plus 1.0 divided by 2. Now the new centroid values for this cluster is 1.25 and 1.5. So earlier the assignment step was done. After the assignment, the new cluster, we understood this one is falling, this one is very close by to this one, and this got assigned to this one. Okay, now the initial cluster is formed. The next step is it has to update the new centroid value. The new centroid value for this one is 1.25, 1.5. Now you compare this observation with this one. 3 minus 1.25 whole square plus 4 minus 1.5 whole square. Take the square root, this one. Now you compare this one, because here in the case of second cluster centroid, there are no cluster formed, right? No change happened, and simply you subtract this one from this one. Sorry, this one from this one. 3 minus 5.0 whole square, 4 minus 7.0 whole square. Take the square root, 3.6. If you compare this observation with this cluster new cluster centroid and the second cluster centroid, still this one is closer to this one only. Hence, even this observation falls part of the cluster 1 only. Right? So now you need to recompute the cluster centroid for cluster 1. The recomputed, the new cluster centroid is this one for cluster 1. Cluster 2, no change happened, right? Because we did not assign any values to the cluster 2 as of now. Now we are left with these 3 observations. Now let us check whether this observation or record is close by to this one or this one. So 3.5 minus 1.83 whole squared plus 5 minus 2.33 whole squared is equivalent to 3.13. And if I compute the distance, the Euclidean distance between these two, right? 3.5 minus 5.0 whole squared, 5 minus 7.0 whole squared, I get 2.5. So this observation is close by to this cluster. Obviously, right? Because this distance, the distance between this one and this one is very close by. Hence, this one falls, or this one falls for part of this second cluster. Since this cluster has new assignment, the algorithm has to compute the new centroid value by taking the average, right? So this is how the algorithm assigns, and it performs the assignment and the updation. Okay, hope you understood with this simple math, right? With this observation, with this example, you are able to understand, right, how the assignment is done. So iteratively, it assigns the value and updates the cluster centroids. As long as there are no more as long as the clusters are stable. What do you mean by clusters are stable? There are no more assignments are required. All the observations are assigned to the respective clusters. So we have something. Okay, now the question is, how do I evaluate my cluster model, right? How do I evaluate my cluster model? We have something called WSS. WSS stands for within sum of squares. The WSS is the measure of how tight on average each cluster is. How tight on average each cluster is. Okay, it is a measure of homogeneity. WSS is a measure of homogeneity. It is a kind of a metric. How homogeneous each cluster is. How similar the observations are there in each cluster. That is what it is. How tight. So in the common sense dictates us, right? When you have more clusters, the observations are very closer to centroids. Look here. In this case, look here. Instead of having 3 centroid, if you have two more centroids, right? So this one will be, the values that are, see, this one will get shifted here, and if you have another centroid here, this one will. So when you have more clusters, the clusters are very tight, right? The tighter the clusters, better. But if you have more number of clusters, it can do overfitting. It can lead to overfitting. Okay, so finding the optimal number of clusters is very crucial. That is what we understood from this one. So how do I find out the optimal number of clusters? We have something elbow method. Okay, I'll show you in my script. It's a very simple script. Okay, so here in the x-axis we plotted the number of clusters, and in the case of y-axis we plotted the WSS within group sum of squares. Within each cluster, how far each values are away from the cluster centroid. That is what this one talks about. Okay, so when you have two cluster, the WSS gets dropped. When you have 3 and 4, it gets dropped like anything, right? Within sum of squares getting reduced. So that means it's called elbow method. Okay, elbow method. But here the elbow is, see, in our hand we have elbow, right? The elbow here. So in this case, by looking at this, we can say after 2 the cluster is stabilizing it. So you can use 2 clusters in this case, right? So the underlying idea of the algorithm is that a good cluster is the one which contains the smallest possible within cluster variation of all observation in relation to each other. That is what W is. We use elbow method to find out or to determine the optimal value for the cluster, the number of clusters. Okay. The elbow of the curve, right? This is the one gives us the optimal number of clusters for the given data. The next one is the important step is when you before you build your k-means clustering model, as part of your data pre-processing, make sure that you are not having any outliers in your data set, because the clusters are sensitive to outlier, like linear regression model. Another thing is you need to have only the quantitative variable. Let's say even if I have quantitative variable, still what you need to do is you need to transform this quantitative variable into, you need to standardize this quantitative variable in simple term. So we call that as a scaling. Why do I have to do scaling? The next question is, why do I have to do scaling? Scaling is required very much. Okay, or we say, they use this term normalization. Okay, normalization. So as part of data preparation, you are supposed to perform normalization. In the interview they'll ask you, okay, what are the tasks that you perform as part of data pre-processing? We address the outliers and we address any missing values are right. We perform data imputation. Okay, apart from this, we perform normalization. What do you mean by normalization? Why should I do normalization? The objective of performing normalization is to convert the values of the numeric columns in the data set to a common scale. Look here, we have age and income. The unit of measure for age is different from this one, right? The age is 30 or 20. Age this column can have at the maximum only 3 digits. It cannot have more than 3 digits. Even the worst case, right? It cannot have more than 3 digits. Whereas in the case of income, it can have any number of digits. If you look at the Walmart, Target, or all the leading retail chains, the monthly monthly, even weekly revenue, right? It is in easily 10 to 15 digits, right? So here uh, we have to, the age and income, or these two variables have two different unit of measure in it, right? So hence these two features are in very different ranges, right? So if you look at here, the income is let's say 10,000 times larger than the age, larger than the age, right? So larger than this age, the magnitude of this one, right? So because of the huge value in the income column, it can cause some problem. It can cause some problem. Okay, see, it is something. One simple analogy is, let's say you have some salespeople reporting to you. You are supposed to give them the incentive, or you are supposed to give them the incentive, or the expenses whatever they encountered. Okay, whatever they incurred. Okay, whatever the expenses they incurred, you are supposed to pay them. It is based on the distance that they travel. Let's say you are paying the expenses. What are the expenses incurred by the salesperson? You cover it in terms of the number of distance they covered. Let's say some guys, they say, some salesperson, they tell you in terms of kilometer. Some people, they say in terms of meters, right? So I travel 1,000 meters. So another guy says I traveled 1 kilometer. Two different unit of measure. But if you use the meter as well as the kilometer values in the single column itself, since the meter value is much more than the kilometer, the meter can influence, right? It will have significant influence on your decision, right? If you don't convert them into a common unit of scale, you will tend to think, oh, this guy traveled more, we'll give him more, will approve him more money, right? It will have, similarly in this case, right, you need to convert the quantitative variable, because the variables, if the variables are in different unit of measure, you need to convert it to common scale. There are two techniques that are available. One is z-score, other one is min-max techniques. They, in general, they use z-score. You can also use min-max techniques. The formula for this is x minus minimum of x divided by maximum of x minus minimum of x. I'll repeat it, okay? Ideally, I should have mentioned it here. Anyhow, x minus min of x divided by max of x minus min of x. That is one technique. You can use it to do scaling, or you can use z-score. Z-score is also a popular scaling technique to perform the normalization. Okay, so in this case, look here, if I use this formula, what will happen? Age and income. The age, I listed all the ages and income here, and I computed the mean, right? So you need to subtract each and every value from 30 minus 28 divided by, this is my standard deviation, 30 minus 28 divided by this one, and 26 minus 28 divided by this one, and 30 minus 28 divided by this one. So after you convert, right, after you perform the normalization, if you look at, right, both the values are somewhat close by. You don't see the higher value in both the columns, right? It is somewhat close, 0.8, 0.95, but it is negative. It is 1.05, 0.86, right? It is not much. The difference is not much. So the normalization is one of the important steps that you need to perform it as part of data pre-processing. Again, normalization is not required for all the cases, but most of the cases we perform normalization, especially in the case of clustering, and even the case of PCA, principal component analysis. When it comes to neural network, XGBoost, we perform the normalization. The one advantage of this one is all the variables, quantitative variables, are in the same, we are converting the common unit of measurement. And the other advantage is the performance will be much faster. Okay, you will not run into floating point overflow issue, those kind of errors you will not encounter. Okay, these are the advantages of using performing normalization on the data set. The next one is, how do I evaluate my model? So what is a good clustering? The intra-class similarity is high, the inter-class similarity is low. So what does that say? Cluster cohesion and cluster separation. Cluster cohesion, how tight my cluster is, how closely related are objects in a cluster. Within the cluster, how close the values are to the centroid. Okay, so if the observations that are very closer to the centroid within each cluster, that means my cluster cohesion is very high. That is good. My cluster is good. At the same time, between one cluster to another cluster, the distance is far off. The far off the distance from one cluster to another cluster is good. Okay, supposing, let's say you have something like this. This is what I'm trying to say. Let's say you have a cluster and you have another cluster. The distance between these two clusters, let's say the centroid, the distance between this cluster centroid and this cluster centroid are too far. That means the clusters are well separated, right? My model was able to find out the similar and dissimilar. It is able to successfully separate the similar and dissimilar observations. Okay, and cluster cohesion is nothing but the observations within each clusters are very closer to the, let's say my cluster centroid is here, all the observations somewhat closer to here. Supposing if one observation is here, one observation is very here, right? That means it is not tight. Okay, and let's assume that, let's take this one. Okay, this cluster is there, one value is there, this is my centroid here, these values are far off from this. That means this cluster is not cohesive. It's not a cohesive cluster. It is not tight. Okay, and other values here, other values here. No, right? So we don't see any values that are close by to this centroid value. So in that case, what can I do? Increase the number of clusters. Probably if you increase the number, instead of using k equal to 3 or 2, you can introduce k is equal to 3. So in that case, what will happen is probably these values can be part of another cluster, and these values can be part of another cluster. It will be tight cluster, and this one will be part of this one. Okay, so right, this is how we evaluate the model. Okay, the between sum of squared should be very high, right? The distance between one cluster center and another cluster center should be far off, and within the cluster, right, that is called WSS. How closely, right? Within clusters, sum of square supposed to be very close. Okay, this is how we evaluate the model. Now the question is, what is the difference between KNN and k-means clustering? In the case of k-means algorithm, we have to specify the value for the k upfront, like k nearest neighbor. Then why do we call KNN as supervised and k-means as unsupervised? In the case of k nearest neighbor, we need to train the algorithm with the label data. You need the label data. Whereas when it comes to k-means, you don't require the labeled data. Okay, and also the k-means algorithm, it uses the distance metric, but it is not based on the nearest neighbor. Right? It is not based on the nearest. You don't have to specify the nearest neighbor, but instead you need to specify the number of clusters that are required. That is based on your domain also. You can do it. Okay. So now the question is, when to decrease the value of k? So can I say k is 4, k is 5, or k is 3? When can I decrease it? If you find any clusters with few data points, does any centroid seem too close to each other? Right? In that case, you can decrease the value of k. Supposing I have a cluster here, if you find any cluster with few data points, let's say in this cluster, this is the centroid, you hardly have 1, 2, 3 values are there. But you have another cluster, but here most of the observations are there, right? Most of the, and you have another cluster right? Another cluster. Here you have right, or supposing something like this, let's somewhat closer to this one, and here more observations are there. Better you can combine these two, just to have only 3 observations here, reduce the number of clusters. Instead of having 3, you can reduce it to 2. Okay, another thing is the like this one, right? The cluster centroids are too close. So in that case, you don't require additional cluster. You can reduce the number of cluster to 2 in this case instead of having 3, right? So let's say 1, 2, and 3. Instead of 3, you can reduce it to 2. So when to increase the value of k? Are there any variables that you would expect to get split but do not see? Let's say in the income category itself, right? 3 groups are there, but here I could see only 2 clusters. It is not showing the third group. In that case, you can increase the value of k. See, you keep that in mind when you build a cluster. When you're using the k-means algorithm or hierarchical cluster, what it does is it gives you the optimal value for the centroid. Okay, it tells, okay, it groups something like, you can plot it. Okay, using the visualization, you can plot it. With this, you are able to understand these 3 different groups of customers, or the payment behavior of 3 groups of customers. But the next step is, by looking at this, you need to query this observations. You need to find out which all records are there in this cluster, and then you need to go through those observations. You are the one supposed to come up with some story. So why these values are grouped together? By taking this observation and by analyzing this observation, only then, right, by analyzing this observation only, you will get to know why these observations are grouped together. Right? When you explore these observations, by querying these observations and going through each and every column, right, you will get to know, oh, these 3, that is the reason why these observations are grouped together. Because these, for example, these guys are having higher income group. That is the reason why it got. So we are the one supposed to do the profiling manually. This is called cluster profiling. Once the cluster is built, right, you need to do the profiling by manually going through the observations in each and every cluster, or by analyzing the observations that are falling in each and every cluster. Okay, you are supposed to do some kind of profiling. With that only you will get to know that. So that is the one you need to share it with your stakeholders. Okay, now I'm done with k-means clustering. The next one is, I have something called hierarchical clustering. I'm not able to open that. One second, let me open some problem with my PDF Acrobat also, I don't know. We have something else called hierarchical clustering. So far we discussed about the k nearest neighbor and k-means clustering. Next I'm going to discuss about the other clustering technique called hierarchical clustering. I don't have the study PowerPoint with me. And anyhow, I already uploaded long back, but when I try to open the PDF file, it is not opening. Anyhow, I have this one. See, in hierarchical clustering, even the hierarchical clustering also falls under the unsupervised machine learning algorithm. As I discussed, as part of clustering, there are 2 types. One is the k-means clustering, other one is hierarchical clustering. And the hierarchical clustering is subdivided into divisive and agglomerative. Within hierarchical clustering, there are 2 types. Okay, the divisive is top down and agglomerative is bottom up. And let us directly jump into this example so that you will be able to understand the definition later. With this example, right, you will be able to understand the definition quickly. Okay, so in the case of hierarchical clustering, especially in the case of agglomerative is bottom up. here it involves, right, 4 steps. To build the agglomerate or hierarchical clustering involves 4 steps. In step 1, it assumes or it consider each and every observation as a cluster. Every observation is or every record is considered as a cluster. And then the second step, what is it tries to find out the closest pair. So these two are closest, right? It creates the pair of closest observations and then it merge it. So these two are closer and it merge it. And similarly it finds the other, see these two are closest pair and it merge it. The merging is nothing but the agglomerate. And then it recompute the distances between the clusters, okay? And then what it does is, this is one pair, and are there any other objects that are closer to this pair? This one is closer to this one, hence this and this one got merged here. The step 2 and 3, right? So find a pair of clusters that is closest and merge them, and then recompute the distance between the clusters. Right? So this one and this one, right? The distance between these two are little close by, hence it merged these two one, and finally it merges these two into single cluster A B C D and A B C D E. This is how the agglomerative algorithm is working in simple term. Now let us go back to the definition. Put each data point in its own cluster, identify the closest two clusters and combine them into one cluster. Repeat the above step till all the data points are in a single cluster. The next one is divisive cluster. In this case, top down. Start with a single cluster. Okay, start with one all inclusive cluster. At each step, split a cluster until each cluster contains a point. Let us look at this example. Okay, in this case, what happens is you start with it is the opposite of this one. Okay, it takes the it will have it considers the entire data as a single cluster, entire data set as a single cluster. But in the case of agglomerate, each and every observation was considered as a singleton cluster. But when it comes to the divisive cluster, it starts with a single cluster, and then it tries to find out within this cluster which all observations are close by, and this one, right? And again, this pair is close by, and within this pair, right, A and B are very close by. It creates the singleton cluster. It's very simple. It's that much simple. Look here, that is what this one says. It is an opposite of the bottom up. Start with one cluster. At each step, split a cluster until each cluster contains a point, single point. Okay, that is what the divisive clustering is all about. Okay, now here also, even in the case of hierarchical clustering, we are supposed to use the distance metric. Okay, that is the one is helpful to find out which pair is close by. And in the case of hierarchical clustering, we have different types of linkages. One is single linkage, complete linkage, average linkage, and word method. What does this single linkage says? The distance between closest elements in clusters, or the closest element from the opposite clusters, right? So here this one cluster, the another cluster, the closest element between these two clusters, that is called single linkage. Complete linkage is the farthest distance between these two clusters, the observation, right? The observation which are farthest between these two clusters. That is what the technique is used in the case of complete linkage. In the case of average linkage, average of all pairwise clusters. It finds out the average of all the clusters. Okay, and the word method I'll explain a little later. In the case of word method also, what happens, right? Let's say you have C1 and C2 cluster. It finds out the difference between the total within cluster sum of squares for the two clusters separately. Within cluster sum of squares, it finds out that within cluster sum of squares, how far each value is away from the cluster centroid. Within this cluster, how far each value is away from this cluster centroid. Right, that is what is it. Total within cluster sum of squares is completed for these two things. and the within cluster sum of square resulting from merging the two clusters in clusters A. So total, so now what happens is, right, the two clusters separately and the within cluster sum of square resulting from merging the two clusters in CAG. After merging these two, right, so what is the total WSS, right? So it is finding the difference between the total within cluster sum of squares for the two clusters separately and the within cluster sum of squares resulting from merging the two clusters. That is what distance is all about. These are the different linkage methods are available in hierarchical clustering. So when you build a model in hierarchical clustering, it generates the dendrogram. So it is not like the circle kind of thing, okay? It is not grouping like this, but here it creates something called dendrogram, right? Dendrogram. So I will give you a demo in R so that you will be able to understand very clearly how these algorithms are works, especially the hierarchical clustering. You will be able to understand when I give you the demo in R and Python, okay? So what is the difference between hierarchical and k-means clustering? K-means clustering is it's a robust algorithm because you can use huge volume of data, whereas when it comes to hierarchical clustering, it is a CPU intensive process because it has to create many clusters, okay, because it creates the pair, so it finds out the distance between each and every observation and then it finds out the pairs, okay, pairs and then merging the pairs, okay, with the nearest observations. So here, but in the case of hierarchical clustering, we don't have to specify the value for the key upfront, okay, no a priori information about the number of clusters required. Very handy to club different data points. The disadvantage, it can handle only few data points and takes exponential time for the high number of observations. Sometimes difficult to identify the correct number of clusters by the dendrogram. That is the drawback with dendrogram. If you have less number of data, then you can go for hierarchical clustering, but it is always good if you use k-means clustering because we are dealing with in real-time scenario huge volume of the data. The k-means clustering is very much helpful in that kind of situation. And also we can use k-means and hierarchical clustering for exploratory purpose. Now let us dive into the implementation part. Let's start with R and see how we can implement the k-means and hierarchical clustering. Yeah, it is already there. Look here, I have a data set by the name of affinity. So B affinity, it is nothing but brand affinity. Let us explore this data so that you will be able to let me see if this is available here. My god, my H drive is not visible here. It is not detecting here. Okay, there is some issue with my hard disk, external hard disk. Better I'll put it in my local drive. Yeah, we are all set. it takes longer time. Yeah, it loaded this data. Look here. This data set is more of like we know very well, right? In Chennai, we have Sangeeta Mobile and what is the other one? Other one is Apurva, right? Apurva. What is the other one? What is that? Purvika. Purvika. Correct. Correct. Purvika is the very popular mobile store. Let's assume that the Purvika they sell different brands of the mobile phone and they have branches across various places, Bangalore and Coimbatore, many places, right? So here, for each and every brand and the corresponding regions, how many number of items they sold it. For example, in Adyar, they sold 101 Apple mobile phone. In Samsung, they sold 14. Okay. Likewise, for different locations, for each brand, how many number of items they sold it. That is the data we have it. Let us see how our clustering technique helps us to find out some interesting patterns from this. Okay. So what I'm going to do is I'm going to directly jump into the k-means algorithm. So Z, I'm using Z here. What is my data set name? BFY. Here I need to do scaling. Z score or min max scaling, I can use it. Fortunately in OR there is a built-in function called scale that is available. It is using Z score. I don't have to manually compute the Z score. With the help of the built-in function scale, I'm going to convert the data set into Z score. Okay, see, I am doing the normalization here, data normalization. See here what I did, I just removed the region column because the region is the text data, right? Text data. I don't, because the k-means and hierarchical clustering requires only quantitative variable. Hence, I removed this one. The next step, what I'm doing is, I'm going to use this in my k-means clustering. Very simple. K-means is the function, and the first argument is your normalized data set name and number of clusters. I arbitrarily I used 2. Z not found. Oh, I did not execute this one. Yes. Look here, my cluster is ready. So as I told you, once you build the clustering model, the output is nothing but your cluster centroid. You will get this cluster centroid. Obviously, you can query the data from each and every cluster also. Okay, the observation you can query it, but the output given by the algorithm is the centroid values. Okay, this is my cluster 1. This is my cluster 2 because I have used only 2 clusters here. For the cluster 1, the Apple, this is the centroid, and Samsung, this is centroid. Okay, and the clustering vector, what it tells us is the first record, right? The ADR, the ADR observation got assigned to cluster 1. The Anna Nagar and Bangalore, right? These two are assigned to cluster 2. And Bhubaneswar assigned to cluster 1. And these, after Bhubaneswar, how many? 5, right? 1, 2, 3, 4, 5. Up to this one, Calicut to Pune got assigned to second cluster. That is what it tells us. In total, we have how many number of records? 25 records only. Right? Here, if you count it here, you will get 25. Okay. And here you can find this one, right? The k-means clustering with 2 clusters of sizes 10 and 15. How many values are there in the first cluster? 10. Second cluster, we have 15 records are there. Fine. So within cluster, sum of squares by cluster, in each cluster we find something called sum of squares 70, and the second one is 62. It's pretty decent. Okay, between sum of square to total sum of square 38. Okay, how far off the clusters, right? For that we use this one. It is 38. Ideally this one supposed to be more. Anyhow, let it be there. Let us explore further. Okay, let us try to plot this one. As I told you, right? So we have something called script plot. This is the function that we can use it to plot the script plot. This is the one is helpful to tell us how many number of clusters we can create it. Look, this is my elbow method. So look here. So after this it is stabilizing it, right? So hence I use 2 here. So hence what I started with the number of cluster value here, it is correct only 2. I created 2 cluster. Visually we will look at it. Okay, we will look at it visually. There is a package called FPC and cluster package, using which we can visualize the clusters, 2 clusters, instead of going by the numbers. Look here, 2 clusters got created. In the first clusters, these are the observations are there. Okay, in the second cluster, most of the values are very close by to your centroid only. The distance between these 2 clusters is somewhat okay. It is not so bad, it is fine. Okay, but if I use 3 cluster, what happens is the clusters are overlapping. This cluster is created on top of this cluster, another cluster got created. You're not supposed to have the overlapping clusters. The clusters are supposed to be well separated. At least in this case it is, though these 2 clusters are not too far off, at least it is far off. Okay, it is separated well, fine, right? This is how you can find out. Now the question is, when I plotted this one using the package like inbuilt package like cluster and FPC, I was able to visualize the cluster. But with that, what kind of insight are you getting it? Nothing, right? You need to manually query the observations that are falling part of the cluster 1. And similarly in cluster 2, you need to take all these observations and you need to manually perform some analysis. Why these observations were part of cluster 2? Why these observations were assigned to cluster 1? You need to check that one. So what I'm going to do is, I'm going to do this one. So what I do is, I take my entire data set, BFI. That is the initial data set, right? Without, this is my data set name, data frame name, BFI, and then kfit dot cluster. Okay, because this is the one will give the cluster thing. And what I do is, next one is, I want to include the branch name also, so that I will get more. If I just see the number, I will get confused. So I want to display the branch name also, and then the cluster segment, the centroid value, everything. Okay, and finally I'm assigning it to, I'm creating a new CSV file. I store the clustered value with the branch name into a file called custseg3. So d-dat1 custseg3.c. Let us go and check. I did not get any error. That means it custseg3 got created. Look here, custseg3.csv. What is the date and time? 8/11, right? November, today, 10:35 p.m. Yes, this is the latest file. It got created just now. Let us open this. Excel is always good. Now we are supposed to do profiling. Look here. With this is my cluster, right? The first cluster. These are my second cluster, which all records got mapped to cluster 1. That is what is there in this data set, along with the branch name. Now I'm going to color this one. I'm going to color this one with something else here. This. Look here. So when you look at this, now we need to do profiling. You need to find out why these branches got assigned to cluster 2. Why these branches got assigned to cluster 2? We need to analyze it. Instead of doing this, let us go back to my the RStudio and just check the centroid values. Earlier we saw the centroid values by displaying the model name. This is my model name, KFIT. Here we could see the centroid name. So can you see any difference between here? We could see some negative values are there in this one, and can you see any higher value here? Here in Motorola on LG in cluster 2 it shows more value. So Motorola, look here, Motorola and LG, right? Higher value, cluster centered value is higher compared to cluster 1, right? So by looking, just by eyeballing this, we are able to understand, right? 200 and above, 300 and above, more number of units we sold in this branch for Motorola compared to these branches. But don't tell me here one is there, here also one is there, and why Hyderabad got to, but it takes into account of all these columns. Based on all the columns, it tries to find out the similarity, right? Maybe the Hyderabad, right, compared to other columns. Look here, 246 Hyderabad, all right, Sony. But when you look at here Sony, the sale is very high. You agree with me or not? Compared to these regions, the Sony sale is very high here. And but in this, when you Motorola and LG is better. Though LG is not so good, it is better than this region. So with this, we are able to understand people, those live in this area, right? The location also drives the sale of the brands of the mobile phone. That is what we are able to understand. So what are you going to do by knowing this? What kind of action plan you can come up? Why don't you tell me something, no? What kind of action plan
So
you
we
can?
can,
Yeah.
yeah, if we know in that area the particular brand is selling more, then we can stock it or plan of it, right?
Very good, right? So what we can do is we can probably stock up more the Motorola mobile phones in these areas. Okay, because in this area, though we stocked up more, the sale is not that good, right? So probably we will stock up more here. That is the insight we are getting it. And in this region, you can stock up more on Sony. But compared to these two clusters, the Sony sale is far better compared to all other brands. But still, you need to stock up more Sony brands on this group, right? This group. And what else? What other insights are we getting it here? An Apple mobile phone, we can see that the sale is more here compared to this region. Stock up more the Apple phone here than here, right? So here, except the 1 and 2 places, these two places, the rest of the places are not that good. But here 1, 2, 3, 4 places. But even if you look at these numbers, these are good. So in this region, look here, right? Egmore and these areas. So this is just fictitious data. Don't think, Conjeevaram, don't argue. Conjeevaram, they buy more Apple and all, okay? So with this, we are able to understand in a matter of jiffy the
So in
purchase
real time,
behavior.
how will we view the data? There? Excel, we have limitations. Right?
Yeah, instead of store it in a Excel file, to store it in a CSV file. See, here I used .csv, right? The same CSV file you store it on your cluster, Hadoop cluster also. Okay, and what you do is you can use Hive. Using Hive, you can query Hive. You can write the SQL query, right? You can write the SQL query, and even in R, you can write SQL query. You have a package called SQLDF, library SQLDF, or you can simply use how to subset the data in R, and we learned about dplyr package, right? Using dplyr, you can query it. You can query what observations are there in cluster 1. In this column, you take it and filter it based on this value, observation, and manually you can check it. Okay, and simple thing is, you take the average of this, and so look here, the average is 75.6, and that is what the centroid gives, right? But still the centroid value, whatever we are getting it, it is not the actual value, that is the normalized data. So what you do is you just, you can use dplyr and compute this one. The average is 106, right? Similarly, you can do this one. The average is, you can do simple averaging on the brand wise, you can do it, and you can say these are the one, and then you can probably use some charts to present to the management. These are the, or the right. See, the Excel sheet, once you do aggregation, right? Once you do some kind of averaging or aggregation, see, let's assume that these are all in ADR 101. This is aggregated value. Last 6 months, how many number of items? This is aggregated data. Aggregated data, you don't need anything. What we do is even real-time scenario, right? We push it our local system. We use Excel sheet or Google sheet. Google sheet, what you do is we put the data, and then Google sheet we don't use it because of security reasons. Take it to your local system and then use Excel sheet and generate the reports and then share it with manager. Yeah. This is aggregated data. It's not item-wise data, right? Item-wise data, what you're saying is correct. It is millions and millions of data. But what you are saying is correct. We are dealing with within one category. For example, in the case of electronics, we have TV category, right? The TV itself, different brands are there, but it is not millions, right? At the max, probably 50 brands will be there. That's all in TV, right? So not much. You can still do perform aggregation. Take 6-month data, perform aggregation, and then give it to your algorithm. See, here I simply gave the data. It is right, but in real time scenario, we take the data. We do some kind of sum total units sold for each brand. Use dplyr and we do group by, or in pandas we use group by in pandas to perform aggregation, and then the aggregated data we are giving it to the algorithm.
How many clusters we can go sustain? Like, is that to only two, or is there any limitation for that?
That's what you can use the scree plot. I told you, right? Using scree plot. The scree plot is helpful in terms of identifying the optimal number of clusters.
Okay.
Right, scree plot. And fortunately, in R, one good built-in package is available. The FPC. FPC is very good. You know, right? If you simply specify the k-means runs, there is a built-in function called k-means runs that is available as part of the FPC package. Specify the data set name and then number of clusters between 2 to 20. Tell me between 2 to 20 which how many number, which one is the optimal number. See, it tells you the best k 2. It tells you this is another way of finding the optimal number of clusters. We don't have to break our head by looking at the script. Sometimes the script plot is also confusing, okay, and this one is far better.
Okay.
But the cluster profiling is the challenging one, okay. So in this case, a region and brand, okay, and supposing you have category wise, subcategory wise, if you want to find out something, right, that is the challengeable thing. But still, the beauty of this one is it takes into account of all the entire data, right, entire record, and it finds out are there any relation, are there any or these two observations are similar in nature, right. It compares each and every columns with every other column, and then it groups it. That's what one guy used to argue with me in the past. Hey, I can do everything in Excel sheet itself. Why the hell should I use clustering here? If I take the aggregation, everything, I do sort on this one, I can find out. But there is a pattern here, right? So if you see this one, right, this one and this one has some kind of pattern. Definitely there will be a pattern here. The combination of all these three columns, there will be pattern here. That is the reason why the clustering is very much helpful. Again, we don't have to do it manually. We don't have to write the macro function, all the things, right? And the clustering is it has the self detecting the patterns. It has the capability of self detecting the pattern. We don't have to detect the pattern. But only thing is, once the cluster has been generated, you need to go through the data and analyze it, why the specific observations are falling into specific cluster, right? So that is the one you need to find out, and you need to check why this is good. Like I did, right? This is a simple example. I have one interesting assignment is there, okay, and the retail data set. I'll share to you work on this and try to get as much insights as possible, okay. Build the cluster on that data and then give me the insights, interesting insights, okay. I'll give you the assignment for linear regression also, and this one also, okay. Start work on it. Okay, next we'll jump into the hierarchical clustering. There is a function called hclust. Hclust is available, but for hclust you need to compute the distance first, okay. So here we did the normalization. Here you need to compute the distance between one observation to another observation, okay. So there is a built-in function fortunately that is available, that is called dist. Here I assign the distance for each and every observation into a variable called distance. When you query this one, you can find it something like this. So how many number of records are there in my data set? In my data set I have 25 records are there, right? Let us do one thing. I'll just yeah, still it is wrapping. It requires more space, it seems. Instead of 300, I'll just give 100. I'll give 300. Yeah. Okay. So the 25 records are displayed in the column as well as in the rows. Okay. So but instead of looking at the entire thing, right, we will look at this one. The closest distance between one observation to another observation, that will, right, based on the distance it will combine the thing, right. I'll just show you in my okay, this is what I'm trying to show here. So 1 2 3 4 5, look here. In this case the 7th observation, record number 7 in my data set, and the 5th one 7 and 5, 7 and 5, if you look at here, okay, it is not coming out clearly here. Okay, anyhow, you just at this moment you just think that distance is nothing but the distance between each and every observations, okay. So I'm using a function called hclust. Hclust is the built-in function. With that I'm going to build the hierarchical clustering. By default it is the complete linkage. You know what is complete linkage? The farthest observations between two cluster, based on which it creates the cluster. I don't know why my system is very slow today. Okay, it is done. Okay, next what I'm going to do is I'm going to use plot HC, plot hierarchical clustering. This is the one, but it is not neat. I'm going to use an option called hang equal to -1, so that all these clusters will be evened out, the shape, okay. And if I look at this in terms of numbers, it is not giving me much information. I'm going to specify the labels. Instead of specifying the record number, specify the region name. Look here, the Calicut and Hyderabad, these two regions, the cell pattern is somewhat same, okay. The Calicut and Hyderabad. Better I'll loop, yeah, this is the one, right. With the distance itself, the computed distance itself, we can find out. Yeah, the 5th one goes down here also. What is the Calicut here? The Calicut and Hyderabad. Calicut and Hyderabad is same, right? Calicut and Hyderabad. The 5 and 7 are same. The 5 and 7. Look at here the 7th one, right? Look at all these observations, the distance between this is 1, 2, 3, 4, 5. Yeah, 5. The distance between these two observations is very less. Look here, compared to all other columns or records, right? 5th record and 7th record, the distance between these two are very less, right? Hence these two are close by, based on which it created a pair. Since these two observations are close by, but again now the Perambur is closer to Calicut and Hyderabad. What is Perambur here? The Perambur is 16th, right? The 16th is somewhat, look here. So you can see the 2.104, which is close to this one, right? 5 and 7 and 16th is also very good. We have another 2, but 2.79. But 2.10, right, is the least value. Hence, this one is closer to this pair. 5 and 7, for this pair, the close one is the 16th one, which is nothing but your Perambur. This is how it is building the dendrogram. Instead of saying cluster, we are supposed to say dendrogram when it comes to the hierarchical clustering. Okay, this is how it builds the cluster. And the next one is let us look at what value stored in HC. It tells us clearly it used complete linkage method to build the hierarchical clustering. The distance metric used here is Euclidean distance metric. Number of observations are 25. Now I want to override. Instead of using complete linkage, use single linkage. Single linkage is the closest observations between two clusters. Okay, when I use this single linkage, it is different here. I am getting different thing here, right? These two are closer and these two are closer, right? It is different. And when I use average linkage, similarly we will find the different pairs that are closer. Now the question is, the default one is complete linkage. So when should I use single linkage? When should I use average linkage? To answer to this, what you can do is, you can compare the complete linkage with single linkage and average linkage. Compare all the three, and then you decide which method is good. Right? So how do I do that? We cut the tree. Look here, this is my complete linkage model, hierarchical clustering, right? HC, and I am going to cut only the 3 clusters. Instead of taking everything, right? Look here, if I click this one, it goes back. I did some kind of hang, right? Yeah, so what I'm going to do is, instead of taking all the clusters, I take only 1, 2 and 1, 2, here, right? So the 1, 2 and then 3. Okay, cut 3, cut tree. We can cut the tree. I don't want to take the entire tree. I just cut the tree into 3 parts. Okay, 3. And similarly, average cluster, right? Average cluster AC. The name is AC. AC, cut tree AC 3. Okay, I'm going to have only 3 segments in it. Now I'm going to use a table function. I'm going to compare the complete linkage with average linkage. The horizontal one is the complete linkage and the vertical one is the average linkage method. If you look at horizontally, in the cluster 1 we have 6 record, and in cluster 2 we have in cluster 1 we have 6 records, cluster 2 we have 17 records, and cluster 3 we have only 2 records. 6, 17, 2. 3 of the 3 cluster, first cluster has 6 and second cluster has more observation, and third cluster only less observation. Fine. Let us use average clustering. Look at the average clustering. In the first cluster, we have 8. So in this case, just 6, right? But in the first cluster, 8, second cluster, 15, and third cluster, 2. At least in the case of average clustering, the values are somewhat balanced well. The cluster values are somewhat balanced. But in the case of the complete linkage, first cluster you have only 6, second cluster you have 17. At least in the case of average clustering, average linkage method, first cluster 8, second you have only 15. Instead of 17 you have 15, and third you have 2. Okay? So compared to these two, average clustering method is better because it separates the data well, right? And each cluster, it has a reasonable amount of values. See here, the cluster, the observations in this cluster is tight, somewhat tight compared to the complete linkage, right? So, but similarly, you can find out, use the table and cut the tree for single linkage and compare single linkage with average linkage and single linkage, complete linkage, and you can decide, right, which method is good. This is how you can decide which method you are supposed to use. And apart from this, we have something called Watts method. Watts method also, so you can compare Watts method, all these 4 methods you can compare it using table function, and then you decide which method optimally distribute the values across the clusters. That is how you need to build the cluster. Okay, you need to determine the best cluster, best cluster linkage. Okay, in the case of hierarchical, but hierarchical clustering, if you have smaller data, it is good. If you have huge volume of data, it is painful. And again, interpreting is also a bit tough here because you have so many clusters, and real time we are going to work with more number of columns and huge volume of data, and it's very painful. Multiple clusters will be difficult to interpret. But it is better you can use k-means clustering. If the volume of the data is less, then you can go for hierarchical cluster also. You can use both hierarchical as well as k-means. But interpreting the k-means clustering is very easier, very simple. But still you need to manually find out which observations are falling into which cluster. And by going through each cluster observations, you need to perform manual analysis, and then you need to come up with the insights on your own. So hope you understood what is hierarchical clustering, what is the k-means clustering, and also you understood how to implement them in R, and Python will show you. And k nearest neighbor also we discussed it. The implementation part also I will show you in Python now quickly. 1 second. Earlier I'll take the same churn analysis. Same thing, you need to initialize the model, and you need to know the method name or the class name for your model. That's all. For linear regression, that is the class name. Logistic regression. And I guess for the naive not naive, so the k nearest neighbor, you have something called nearest neighbor. 1 second, let me just show you here. Nearest, right? So yeah, nearest. Look here, k neighbors classifier. This is the class you need to import it from this package, and you are initializing this. You are creating an object here, knn, and then you need to first initialize the model. The next one is you need to train the model with the independent dependent variable and check the score, right? The accuracy, right, like this one, and compare this one with other model. And if the usually the k neighbors is not that good for this one and all. Okay, so check the accuracy of logistic regression and nearest the neighbors, right, k nearest neighbor, and whichever model's accuracy is better, that is the one you are supposed to use it. That is the one you are supposed to plan to migrate to your production. The production deployment, we'll discuss it in the other session. So this is how you can implement the k nearest neighbor. And we have something called Gaussian naive-Bayes. Naive-Bayes is there. Okay, naive-Bayes is a very simple algorithm. sklearn dot naive-Bayes, you need to import Gaussian NB. So initialize the model and then train the model. Using fit, we train the model. And then what we do, we predict, and then we find out the accuracy for the score for both the training and test data set. Look here, the training data set score is 0.86. The test data set score is somewhat close by. You don't see overfitting in the case of naive-Bayes, right? In this case, it is good. And also the precision recall also somewhat better. Even the F1 score. We discuss about importantly, yeah. The next thing what I am supposed to discuss is validating the classification related models. Okay, we'll discuss it later. If time permits, you can watch my video in my YouTube channel. Okay, we have I don't know if you have watched my net is very slow. In this you have something called this is the one. Okay, yeah, part 1 and part 2. Part 2 you watch it, and part 1 you have something called part 1 and part 2. Okay, forget about this one, or you can watch this one also. Instead of this one, right, you can better watch this one, part 1 and part 2. Okay, and confusion matrix part 2 and confusion matrix part 1. You can watch this one because different batches I took it. Yeah, this is the one. Yeah, this is the one, you can use it. Okay, or I will send you the link, don't worry. Okay, don't get confused. Okay, here so many videos are there. I created off late, I started created the playlist. Better I will share these two videos link, right? You can watch that video. Anyhow, I'll discuss this in the upcoming the next weekend. Next weekend is going to be festival, right? We will, because festival we are all busy, and followed by the next weekend we will continue. Okay, 22 and 23, and let us see if if you are free sometime next week or so, right, after festival or before festival, you get back to me. During the weekday itself I can finish it off, but in the meanwhile you just go through on that two videos, the confusion matrix, the precision recall, when you are supposed to use precision, when you are supposed to use recall, and what is F1 score. All these things I discussed there. Okay, you just watch that video. And still what we will do is we'll create, if you guys can create one day during weekday or so, right, I can walk you through that. Okay, next one is very simple algorithm. Please bear with me, we'll finish it off the other algorithm also. Okay, the last one is this one. My disk problem is there, or disk is not getting detected. H drive is okay. H drive, I got it. We have something called naive-Bayes. Naive-Bayes is also very simple algorithm. Or else I'll go to my website. Only thing is the deep learning algorithm are bit challenging. Even neural network also bit challenging, especially when I explain about the gradient descent algorithm and all. You need to spend more time to understand that one. One second. Yeah, introduction to naive-Bayes. So naive-Bayes algorithm is also a supervised machine learning algorithm. The naive-Bayes algorithm is used mainly for classification purpose. You cannot use it for solving the regression problem. It is meant for classification problem only. Okay, to solve the classification problem. So the use cases are like spam classification, sentimental analysis, and classifying news articles. In that kind of situation, you can use Naibase. Though using Naibase algorithm, you can solve the classification problem. You cannot use Naibase for all classification related problems. What do you mean by all classification? In simple term, if you have structured data, in that case, if you use Naibase, it is not much helpful. It is well suited for unstructured data. Okay. So it was this algorithm. The basis for this algorithm is Bayes theorem. Bayes theorem was developed by Thomas Bayes between this period. It can be seen as a way of understanding how the probability that a theory is true is affected by a new piece of evidence. It is a probability based classifier. You need to remember this. The Naibase algorithm is a probability based classifier. Even the other classification related algorithm also, we can generate the probability, we can assign the probability, but it is based on the Bayes theorem. Okay, it is based on the Bayes theorem, but in this case the definition is a bit different. Okay, the formula is different. Look here, we are going to estimate the posterior probability, right? The model, the algorithm is going to estimate the posterior probability of an event. Okay, the equation for the Bayes theorem is this one: probability of A given that B. What is this straight line? It is nothing but given that B. What is the probability of A given that B has already occurred? Okay, and E is equivalent to the likelihood into class prior probability in predictor prior probability. So it is just an opposite of this one, right? The probability of B given that A into probability of A and probability of B. This is also very yesterday I discussed about a data set called playing tennis, right? Let us take the same data set. One second. It is a bit slow. It is not displaying the entire content. So if you get stuck up something like this, press F5 so that the entire content will get displayed. I will try to fix this one. Let me, I just see, I open the okay, it is something like okay, supposing you wanted to predict what is the probability given that John equal to play, right? So if I ask a question like this, it is kind of vague, right? Let us say what is the probability that John will play equal to yes here. You just think about in the place of A, play equal to yes is there. Given that Sunny, okay. 1 second here. I just it is not going beyond this. Let me just or just give me a second. I'll just check my PowerPoint. I just stored it somewhere. Yeah, it is there already. because I have some data is there. With that data, if I explain, you will be able to understand. Just give me a second, right? It is trying to load. I'm just wondering why my system is very slow. Naive base. Second, the naive base is not coming here. Because if I finish it today, you will have more time to review, because the next weekend also we don't have session. Even if we have session, it will be, we can do some sort of fast tracking it. Naive base. I don't know why it takes longer time. So okay, anyhow, I will cover this later. Okay, the k nearest neighbor, because I have some data set with that. I thought of showing it. It is hanging here. I'll show you to later. Okay, it's a very simple algorithm. In the case of naive base, it makes an assumption that each and every attribute is independent of one another. Okay, that is what you need to remember it. These are all there in my secondary hard disk. That's the reason why it is causing a lot of time. Anyhow, not a problem. Okay, it is already 11:15. Okay, and we will plan it some other day during the weekday. I will check with you all. If you are okay, we will have one session during weekdays. That time I will cover naive base, and also we will continue that one, how to validate the classification related algorithms. Okay, we have something like accuracy, precision, recall, FN score, and confusion matrix, how to interpret. If you know that, that is more than sufficient. Plus we have something called receiver operating characteristic. Or by the way, I will send you the link for the videos. You can watch it. Okay, 2 links I will send it. If you watch that, that is more than sufficient. Okay, but still we will have one more session to walk you through that, and then we will continue with the other algorithms with other people. Okay, so any questions so far whatever I covered?
No, no, sir.
Nothing, right? So fine, so in that case, we'll share the video, today's session video, and also the files, the script file and dataset, everything is available in the GitHub. The link which I shared yesterday, that is the one having all the data and the script in it. And Python also I will give you the demo. Okay, and whatever the pending things are, right, we'll cover it in another one day. Okay, we'll plan it forward. But to help you understand the metrics for the classification related algorithm itself will take 2 hours time. Okay, so many things are there. We'll discuss it. Okay. Instead of first you watch that video. I will have to cover logistic regression. Logistic regression yet to cover, right? Yeah, logistic regression, that is the one thing pending. If I cover that one, and then if I cover the metrics part, it makes sense. Because for logistic regression, there are specific to logistic regression, certain metrics are there. Okay, you need to understand that one also. That video that is there. If I share that, you will get confused. Okay, we will plan it. Okay, we will plan it one day during the weekday for logistic regression. And as part of logistic regression itself, that session itself, I will walk you through the metrics. Okay, I'll try to walk you through that one. We'll have one session to cover everything. Okay, fine. Okay, since you don't have any more questions, right? We will circle back sometime during the weekday or so, right? We'll find out mutually which day is better, based on which we'll have a session. Okay, to cover. If you spend only one day, right, logistic regression and the classification metrics for one day, that is enough. Okay, and we will circle back post the Diwali. Okay, you can spend time with your family during the festival time, followed by the next weekend we'll continue. Okay, but in between, one day is sufficient, right? You get back to me. Okay, thanks. So good night, take care.